is what we call the radical function, or better known to some of you as the square root. All right, the parent function is going to be f of x equals the square root of x. All right. Now, this is probably the trickiest one to graph. Only because there's only certain numbers that are perfect squares. So we want to make sure that we kind of pick those because it makes it easier. So here's our x and here's our f of x. So for this one, we're going to start at 0, 1, we're going to go to 4, 9. And that's all we'll do because we can't really show our 16. But remember, we don't use the negatives because our function is undefined if it's a negative. We can still take the square root of a negative. We're going to talk about that not next unit, in 2 units. We'll talk about imaginaries. But for now, we're only looking at positive values. Okay, so what's the square root of 0? 0. Square root of 1? 1. Square root of 4? 2. Square root of 9? 3. All right, so we plot this. 0, 0, 1, 1, 4, 2, and we're going to say 9 is over here somewhere. There's 9, 3. All right, so this shape kind of looks like half of a parabola. So we could make it a parabola if we added another side, but we're not going to worry about that. So here is our square root function. It has the trickiest domain and range. Our domain, because notice that we only look at part of our x values. We're not going negative. So x has to be greater than or equal to 0. So as we move this point, which is not really a vertex, but we're going to just call it the vertex of the square root function, as it moves, that's going to move our domain. But an easy way to think of this is going to be our h value. Your range then is kind of going to be the same way. We're looking at our y values. Because we're going positive, we're going to be greater than or equal to 0. And this is going to be whatever your k value is. So kind of keep that in mind. That'll help you at least figure out part of your domain and range. And then last thing is the transformation. All right. So we are going to write it down. It's the same thing. A, h, and k still do everything the same. It's a square root of x minus h plus k. Notice that the radical ends were k ends. The plus k is not part of your radical. That's going to be very important to keep in mind. Okay, let's take a look at how we do this. So we have the function f of x equals the square root, let's do negative x plus 5 minus 1. Now, we talked a little bit about this at the beginning, but what happens when that negative is inside of our function? It's now going to flip over the y-axis. So this negative is going to reflect over the y-axis. And I'm going to show you just how we do that. It's a little bit different than what we're used to. Okay, this is under the radical, so it's our h, which is equal to negative 5, which means we are going left. And this is our k. It is negative 1. So we're going to go down. Okay. we are going to, for right now, ignore that negative, and we are going to create a chart. Now, you kind of have to do a little thinking, because like I said, we can't square root every number. So it's kind of nice when you pick the good numbers to square root. So let's think about this. If we have 5 and we want to make it a square root, we could go down to 0. So that would be a -5. Because think of this now. We have -5 plus 5, which is 0. The square root is 0. Minus 1 is -1. Okay, we can make it go to 1, which would be a -4. So let's do -4, which means that 5 minus 4 is 1. Square root of 1 is 1. 1 minus 1 is 0. Okay, we can make it go to 4, which means we need a -1. So that means that we are going to say square root of 4 is 2. 2 minus 1 is 1. And let's make it go to 9, which means we need a +4. So that gives us square root of 9 is 3. 3 minus 1 is 2. Okay, I'm going to plot this in this orange color. So we are at -5 and -1. We're at -4, 0. We are at -1, 1. And we are at 4, 2. Now, I'm not going to worry about connecting this yet. The next thing we have to do is flip this over the y-axis. So we're going to think this point is at -1, and it is 1, 2, 3, 4, 5 away. That means, and I'm going to plot the new one in pink, we're going to go 5 to the right. 1, 2, 3, 4, 5. We're just folding it and creating that mirror image. This one is 4, so we go 4. This one is 1, we go 1. And this one is 4. 1, 2, 3, 4. So, would you agree, just looking at this, if we folded that in half, the orange and the pink would meet up. Okay? And then we draw it in. Alright, let's try this out. What do you think our domain would be? X. Now, do we go greater than or do we go less than? We do go less than, and we are less than 1, 2, 3, 4, 5. So we go less than 5. Your range is going to be y. Do we go greater than or less than? We go greater than, and it's greater than -1. So, like I said, radical is a little tricky, but it's still the same thing. And once again, we're going to work on this in class with a graphing calculator lab so that you can see it. But the reason that we had to think of it without the negative is because if you have a negative number in there, all it's going to do is it's going to end up telling you that your answer is undefined, because we don't know how yet to take that square root of a negative. But our function for a square root is only defined when it's positive. So this is the best way to do it. Hope this helps.